Let's go ahead and get things going. Any questions? Any thoughts, comments before on the last session before we go ahead? All right. Well, an open invitation. If you see me hanging around, just come up and if you got questions or want to discuss some things a little bit further, I'm happy to do that. So don't hesitate to come up and ask me questions that you might have. All right, I'm curious. Did any of you collect comic books when you were younger? A few of you?
Comic strip books count?
Huh?
Comic strips,
Sure, yeah. So, do any of you still collect comic books? Well, I actually had a comic book collection when I was a little kid, and in recent years I actually started collecting comics again. So, because some of those things are worth quite a bit of money. But anyway, all that aside, but my comic book collection when I was a little kid was really a weird collection of comic books because most of my comic books didn't have covers on them. So I had comic books without covers. And the way I got those comic books was going down to a corner store called Fannon's Market that was just off the grounds of West Virginia Institute of Technology. So here's an iconic picture of WVIT, which is my father taught physics at WVIT, and this is the administration building. There's like a set of stairs that go forever and ever and ever up to the top of the hill. This campus is built on a hillside. This is the student center. The building my father taught in was over here. And so when I was a little kid, I would play on the campus grounds all the time. That was my playground. And college students would drink. They were very messy, and they would drink soda pop, and then they would throw the pop bottles on the ground, and I would go around collecting them because you could cash them in for a nickel a piece at Fannon's Market. And so I would do that and then usually cash them in and get a candy bar, which in those days was, believe it or not, 10 cents. So all I needed is 2 pop bottles and I could cash it in for a Hershey's chocolate bar or something like that. And one day I go into Fannon's Market and he had a whole stack of comic books that you could get 10 for a dime, but none of them had covers on them. And so I thought, well, this is a great deal. So I would now go collect pop bottles and get comic books from Fannon's Market and then take them home and read them. Now, I later learned that what he was doing was the local drugstore, which is where the newsstand was, where you could buy comic books from, if they didn't sell comic books at that time, what they would do to demonstrate to the distributor that they didn't sell the book is they would tear the cover off and then they would ship the cover back, which was proof that they didn't sell that particular book. Therefore, they didn't have to pay for that particular comic, right? So I can't imagine anybody tearing the cover off of a comic book, but that's what was done. And so Mr. Fannon somehow got a hold of these old comics with the covers off, and then he turned around and resold them in his store. But anyway, that process of buying comic books meant I was pretty indiscriminate, that I would get any kind of comic book I could because it was essentially a penny a piece. So I'd even get like Richie Rich and Little Lulu comics and things like that. But this is where I was introduced to a comic called Ripley's Believe It or Not. Are you familiar with that comic? Yeah, some of you are. Nick is. Anybody else? Well, this is a comic franchise that began in 1918, drawn by Robert Ripley. And it typically consisted of a single panel in which he would describe something that was an oddity in nature, an oddity in the world, that was so hard to believe that you would ask the question, believe it or not, right? And it turned out that everything he depicted in his comic was actually true. He never depicted anything that wasn't true. And so there was a team of fact finders that actually would confirm everything that the artists would draw for Ripley's Believe It or Not. And Robert Ripley actually traveled in his lifetime to 200 countries over the course of 30-some years looking for odd facts that they could draw about in the comic strip. So he was considered to be this world adventurer, where in the early 1900s people admired him and were interested in his world travels, which again were communicated, or things that he learned were communicated through his comic strip. In 1929, he syndicated the comic. At the height of its popularity, there were 80 million readers a day, which is remarkable. This would have been the early 1920s, 1930s, or in the 1930s, 1940s. He eventually developed a radio show where he would talk about hard-to-believe facts. And then ultimately, he syndicated a TV show that lasted for a year and was canceled after he had died. And his name lives on today in the Ripley Believe It or Not franchises. And so if you go to places like Hollywood, California, other places, there are these Ripley's Believe It or Not emporiums that are essentially a tribute to Robert Ripley. But as odd as things might have been that Robert Ripley depicted in comic books, when it comes to science, there's some pretty odd things that have been discovered, things that you might call believe it or not discoveries. And one of them was published in 2005 by a paleontologist by the name of Mary Schweitzer, who is at North Carolina State. And she got a hold of a piece of a T-Rex bone that dated at 68 million years in age. And as she was examining the bone and dissolved away some of the bone components, some of the mineral components, what was left behind were these flexible tube-like structures that were transparent, and inside of them were these structures that looked like red blood cells. And then she also discovered these cells, which are called osteocytes, which are found in bone, and including these really delicate filopodia that characteristically extend from the surface of osteocytes. She analyzed the samples and discovered evidence for heme, which is the component in hemoglobin that's found in red blood cells. She detected evidence for collagen fragments in the bone. Collagen is part of the connective tissue that's found in bone. And discovered some other markers for proteins that you would expect to be associated with bone tissue. And this was shocking to people because the expectation was that there's no way that soft tissue materials could survive in fossils. People thought that these soft tissue materials would have degraded, decomposed very quickly after the animal died and before the fossilization process was completed. So this was something that was incredibly controversial, but turns out to have been verified with subsequent studies. And since that time, people have made a number of discoveries of soft tissue materials associated with a number of different fossil specimens. For example, a duck-billed dinosaur specimen that dates at 80 million years in age gives very similar kind of patterns that you see in the T-Rex femur. A triceratops that dates at 68 million years shows evidence for osteocytes. People have discovered fossilized eggshells and have been able to extract pigments that would have, from the eggshells, and from these pigments they can even determine that the eggshell was probably a blue-green type of color. This is from these are from dinosaur eggs. They even detected evidence of ovalbumin, which is the protein that makes up egg white, associated with these specimens. People have discovered fossilized feathers and have been able to extract evidence for remnants of melanosomes, which are the organelles that give the pigmented color in skin and in feathers. They just have recovered eumelanin and pheomelanin from the fossilized ink sac of a cephalopod that dates 150 million years in age. They've recovered keratin from the skin, fossilized skin of reptiles, and then other molecules as well. We don't need to get into this. You guys get the idea here. And so this is, again, something that's rather shocking, but seems to be valid, is that soft tissue materials can survive in fossils. And again, this is something that nobody anticipated, nobody would have expected. And this kind of discovery has given fuel to people who hold to a young Earth creationist position, arguing that this is evidence that the fossil record cannot be tens of millions or hundreds of millions of years old, that the fossils must be relatively recent, and that the best way to explain the fossil record is that it's the result of a global flood that happened recently. In other words, people argue that this is very powerful scientific evidence that we live in a young Earth. And so this is what Kevin Anderson, a biochemist who died recently, said. If soft tissue is original, then a very plausible interpretation is that these dinosaur fossils are actually young. This younger age contradicts the standard dating methodology used to originally establish the fossils' ages as more than 65 million years. Such contradictions draw the entire geological dating paradigm into question and further exposes the error of accepting evolution as a presupposition for the dating paradigm. Now, there is some merit to the points that Kevin Anderson is making, because we know that there are a number of mechanisms that can break down tissue, soft tissue, upon the death of an animal. Water will lead to the hydrolysis of the molecules that make up tissues. If the environment is alkaline or if it's acidic, that will accelerate the decomposition. Oxygen is actually a really nasty chemical. I don't know if you guys know that or not. Oxygen, we depend upon oxygen. That's how we breathe. That's how we engage in respiration. But what happens is that our bodies have mechanisms that detoxify oxygen, and we couple those detoxification mechanisms to the process of extracting energy from the nutrients that we eat, from the food that we eat. And so for us, oxygen becomes vitally important for our survival. But oxygen is a horrific compound. As a chemist, oxygen is one of the compounds that actually frightens me most. And there's oxygen is a gas. You can liquefy it at cold temperatures. Liquid oxygen is a very dangerous material. So oxygen in the environment is going to oxidize or break down the molecules that make up soft tissues. Microorganisms will consume soft tissues. There are environmental enzymes that will break down these tissues. So the point is that Kevin Young actually has a point. And then on top of that, some scientists who hold to a young Earth creationist position have actually done radiocarbon measurements on, for example, a Triceratops horn that gave evidence for osteocytes. And they argue that the horn itself dates at about 41,000 years, and the bioapatite, which is a part of the bone, dates at about 35,000 years before the present. And so they argue that this is an indication that these must be, again, that these samples must be young. Now, I'm someone who holds to an old Earth position. I take the view that the Earth is 4.5 billion years old, the universe is about 14 billion years old, that life has been on Earth for 3.8 billion years. And I also look at Genesis 1 as being a historical account of God's creative work. I just see day as a period of time as opposed to 24 hours. And so there is an in-house debate that takes place among Christians that are interested in science faith issues as to what is the best way to understand Genesis 1 and the days of Genesis 1. Are they 24 hours or are they long periods of time? And the scientific data unequivocally seems to indicate, again, the antiquity of the earth, the antiquity of the universe, the antiquity of life on earth. And so would argue that the best way to read Genesis 1 is that these are periods of time, not 24 hours. The days are periods of time, not 24 hours. However, this discovery of these the discovery of these soft tissue remnants in fossils raises questions about whether or not, the fossil record has been properly dated, right? This is a legitimate question. And so I wrote a book a couple of years ago called Dinosaur Blood and the Age of the Earth. And in the book, I use Ripley's Believe It or Not as kind of a way to introduce each chapter, and in the contents of each chapter kind of connect to certain Ripley, Believe It or Not exhibits in the Ripley's Museum. And so the cover of the book was designed to look like a comic book. So anyway, there you go. And so what this book is an attempt to do is to make sense of the discovery of these soft tissue remnants from an old Earth creationist perspective. And so what Kevin Anderson said is that the discovery of this preserved tissue has three possible interpretations. The material is original tissue that was preserved for millions of years by some physical process. The material is original tissue that requires no special preservation because the fossil is only a few thousand years of age. Or the material is not original tissue, but the product of a microbial biofilm or other contaminating process that mimics biomolecule containing tissue. This third option has been pretty much eliminated by everybody in the scientific community. So we're going to be focusing on these first two. And the first one is, we're going to focus on the second one first. The material is original tissue that required no special preservation because the fossil is only a few thousand years of age. And so that leads us to this question, is radiometric dating reliable? Because the age of the universe, the age of the Earth in particular, as well as the antiquity of life on Earth is largely determined by radiometric dating. And there's this oftentimes, there's this claim that often appears among Christians that radiometric dating is unreliable. And I'm of the opinion that radiometric dating is actually reliable. And in fact, there's one way that we can demonstrate the reliability of radiometric dating without even understanding anything about the technique at all. You don't need to understand how radiometric dating works to be able to demonstrate that it's valid. And there's two ways that you can do this. One's called through method validation, and the other is through cross-correlation. And what I mean by validation, whenever you as a scientist develop a method to measure something, you want to validate that method. You want to show that the method is reliable. So how do you do it? Well, you develop a method, and then what you do is you put together samples with known quantities of material that the method is supposed to measure, and then you measure it with the method. And if you get the result that you expect, then you conclude that the method is valid. If you get a different result, then you would conclude that the method is not valid.
How could you do that for something that's supposed to last for 50 years?
I'll show you in a minute. Cross-correlation involves comparing the results of one method with another method. So if a method gives valid results, you'd expect that the results of that method would match the results of another method used to measure the same thing. That's called cross-correlation. And so when it comes to validating radiometric dating, you can actually with the bristlecone pines that are found in Northern California, develop essentially overlapping tree rings. That is, tree rings form basically every year. And so you can get the age of a tree by counting the number of rings. If you cut the tree down and you look at the stump, you can count the number of rings. And so what you can do is actually match the rings from one tree with another. And so you can actually reconstruct a history that goes far beyond the lifetime of a tree by looking at overlapping tree rings. And for the bristlecone pines, you can go almost 12,000 years. And it turns out that if you use carbon-14 dating from samples in these bristlecone pines, you actually get dates that correspond to what you think that particular age would be for that particular tree ring. And so you can actually demonstrate the reliability of carbon-14 dating, and hence radiometric dating using this method. This would be a type of method validation.
How can you do that with overlapping trees if the tree doesn't actually go back to that long ago?
Well, because you would say this tree may have lived for 400 years, let's say from 0 to 400. This tree may have lived from 300 to 600, and then the tree rings would match in the two tree stumps.
But we don't have a tree from 12,000 years ago, so how can you overlap that far back?
Because there would be trees that would be that would have left behind their remnants that you can pick up the rings in them that would go back that far.
Hard time believing in California of all places that evidence.
Well, I mean, you would have petrified tree stumps and things like that. Yeah. All right. Another piece of validation would be the eruption of Mount Vesuvius erupted nearly 2,000 years ago, 1,937 years ago. At the time I prepared this slide, so this is going to be a little bit longer. But so we know when Mount Vesuvius erupted, and using a technique called argon-argon dating, you can actually go and measure in the volcanic ash the time of the eruption, and the eruption basically matches from the radiometric dating when the historical records show. So the point is that we can show using independent methods that radiometric dating is valid. Now, we can also do cross-correlation because there's not a single radiometric dating technique. There's probably 40 or so different radiometric dating techniques using different radiometric isotopes. And so, for example, the oldest rocks on Earth date at about 3.8 billion years in age. We have zircons, which are minerals, that you can actually measure their age because of radioactive isotopes in them that actually date to between 4.2 and 4.4 billion years in age. We have Martian meteorites that have been recovered that date 3.8 billion years in age. We have rock samples from the moon that date 4.25 billion years in age. And we have meteorite samples, a lot of them, which are believed to be are remnants of the oldest materials in our solar system that date at 4.5 billion years in age. In other words, we have this really consistent picture of the early Earth and the moon and Mars and our solar system from these radioactive materials, which all give this coherent story, this consistent story. Also, we know that there are no short-lived isotopes in the Earth's crust. And why is this important? Because the rule of thumb is that a radioactive isotope is going to persist 10 times its half-life, right? After about 10 times its half-life, you would see no more of that radioactive isotope around. And so the fact that we don't see any short-lived radioactive isotopes means that the Earth simply can't be young. And in fact, there are no radioisotopes present on Earth with a half-life less than 500 million years, meaning that if the Earth is 4.5 billion years in age, that result would make sense. But we know that these materials must have been present because we can see their decay products in the crust. So the point is, again, that this is another type of method validation. We also note that if indeed the Earth is young, we would expect all the rocks on Earth to date approximately the same age. And they don't. We have ages for rocks that span the gambit from 3.8 billion years to more recent. Now, young Earth creationists have argued that the reason why we see these types of results is that we're assuming that the decay rates, radiometric decay rates, are constant. But we know that these decay rates, they argue that these decay rates could have changed, let's say, on the third day of creation, or they may have changed at the time of the fall. That there would be these catastrophic changes in creation that would cause the decay rates to change. But we know that this isn't the case because when we look at the sun, the light that's coming to us from the sun emanated from the sun 8 minutes ago, because this is the time it takes for light to travel through space. There's a star called Sirius that's 9 light years away. The Orion Nebula is 1,500 light years away. The Cat's Eye Nebula is 3,000 light years away. The NGC 869, 864 object is 7,000 light years away. Cassiopeia is 10,000 light years away. And if there were changes in the laws of physics that would correspond to changes in the decay rate, the radiometric decay rate, we would see it in the light coming from these objects, and we don't. We don't see any evidence for changes in the laws of physics. So the point is that you can't argue that the decay rates have changed, that they seem to be, that everything we know is that they're constant, that, again, the observations we make about the age of the rocks on Earth and the types of isotopes and the consistency that we get from radiometric dating all works together to paint a picture that indeed the Earth is 4.5 billion years in age. Now, what about the carbon-14 that was found in the dinosaur bones? Well, carbon-14 is actually a radioactive isotope that's constantly being produced. When high-energy radiation impinges on nitrogen, it converts some of that nitrogen in the atmosphere to carbon-14. And so because of that, carbon-14 is ubiquitous in nature, and there's always a carbon-14 background. And also you can get carbon-14 generated if there's any nitrogen in that specimen. And there would be some nitrogen present because nitrogen is an atom found in living systems. And when those life forms die, there's going to be trace nitrogen present. And the radioactivity in the environment would react with the nitrogen-14 to convert it to some carbon-14. There could actually be contamination as well. And so when we look at the amount of carbon-14 we would predict to be in the horn and the bioapatite, if it was 3,000 years old or 6,000 years old, and the amount that's measured, what we see is that the amount that's measured, it would be consistent with it being either contamination or background carbon-14, not with it being from original tissue samples. So the point is that there's nothing to suggest to us that these specimens are actually, these fossils are actually a few thousand years old. That any test that we apply to measuring the age of those fossils with radiometric dating passes the validity of those results. which now leads us to the question, is there any way that the original tissue could be preserved for millions of years by some type of physical process? Right? Can soft tissue materials survive for that long? And the first thing that we need to note is that we need to make sure we understand what exactly it is that scientists have discovered. Scientists haven't discovered red blood cells. They haven't discovered intact collagen molecules. They've discovered the remnants of these materials that have undergone chemical alteration. Jack Horner, in his book, How to Build a Dinosaur, says this: I should point out also that calling the fossils red blood cells is a shorthand way of speaking that may be a bit misleading, just like calling a fossilized femur a bone. It's not a bone in the sense that a femur of a recent dead cow is a bone. Minerals in the dinosaur bone have been replaced. Chemical changes have occurred. What Mary was seeing would, if they were real, be remnants of red blood cells with some of the original chemicals remaining and some of the structure, but with other parts changed forever. So in other words, people aren't discovering intact original tissue. They're discovering the remnants of tissue that have been remained. So for example, collagen that's been discovered is actually not the full molecule. It's just a fragment of the molecule. And I'm not going to get into the technical details here. If you're interested, we can talk about it. So the question is, how then does a soft tissue survive for millions of years? Well, the way we can understand it is that there are two opposing forces at work. That once the animal dies, that decomposition is going to start taking place. And the idea would be that if it was complete, the decomposition would completely and utterly destroy any soft tissue material and any of the molecules that would make up soft tissue material. You also have a process of mineral entombment, where during the course of fossilization, the original minerals in the bone are being replaced with minerals from the environment that are migrating into the bone. And that if you can at some point entomb that soft tissue material before decomposition is completed, that it will protect it and it will either slow down or completely arrest the decomposition process. So to help us understand what's going on, are any of you familiar with this particular comic, The Walking Dead, Robert Kreitman? Right? Or Robert Kirkman? Right. Yeah. Well, if you're not familiar with the comic, maybe you're familiar with the TV series, right? Okay. So you know that in The Walking Dead, that there are the survivors, right? So you can think of the survivors as the soft tissue. There's the decomposition mechanisms. You can think of that as the zombies. And then there's the mineral entombment, which is the shelter, right? And so the idea is that the zombies are coming at you constantly, and the only way that you're going to survive is to find some way to shelter yourself from the zombie onslaught. You also know, if you watch the show, that there are certain characters that just don't have what it takes to survive in a world where there's a zombie apocalypse, right? And there's other people that are tough and hardy and are going to be able to survive. So you know that some people are just simply not made for that kind of a world, and they're not going to make it. And that's the same thing with molecules. Some molecules very readily break down. Other molecules actually are highly durable materials because they have certain chemical properties that make them highly durable. And it turns out that the molecules that survive are molecules that have chemical properties that we understand that make them inherently durable. We also are learning that what we thought to be mechanisms that would cause decomposition actually in some circumstances can contribute to preservation. So water can cause hydrolysis, but there are some biomolecules that don't like water, and when they're exposed to water, it actually causes them to tighten up their structure, which makes it harder for them to break down. So water can cause hydrolysis, but it can also protect molecules or regions of molecules. Oxygen will break down molecules, but it can also cause cross-linking, which gives durability to molecules. Acid and alkaline can cause hydrolysis, but they also have an antimicrobial effect, meaning they prevent microorganisms from breaking down the soft tissues. Microbes will consume the soft tissues, but they also secrete this extracellular polymeric substance, which actually promotes mineralization and entombment of the soft tissues. Iron can cause cross-linking. It has an antimicrobial effect. There's going to be iron associated with red blood cells. Mineral surfaces can absorb and cross-link materials and can protect materials from environmental enzymes. So hemoglobin has an antimicrobial effect. Heme is an enzyme inhibitor. And so the point is that there are these mechanisms that slow down the decomposition process, right? So it's not just simply the tissues are going to decompose, but there's other mechanisms that are keeping them around, and all they have to do is stay around long enough for mineral entombment to take place, and once that happens, those materials are preserved forever. So again, once that mineral entombment takes place, decomposition comes to a halt. So the point here is that this idea of these soft tissue materials that are found in fossil remains is perhaps today one of the leading pieces of scientific evidence that young Earth creationists would bring to bear to argue that the Earth must be young. And that when we carefully examine those claims, what we end up discovering is that this claim doesn't withstand scrutiny, and that the scientific evidence for the antiquity of the Earth and the antiquity of life on Earth is valid, and that reading Genesis 1, where day is a period of time as opposed to 24 hours, is, in my opinion, the preferred reading of the Genesis 1 text. And what we need to do when we think about these kind of claims is to function like Norbert Perlroth. This is a picture of Norbert Perlroth. He was the right-hand man of Robert Ripley. He was Robert Ripley's chief fact checker. So people would send letters to Ripley's Believe It or Not all the time, suggesting weird things that they could actually draw in their comic strip. And Norbert Perlroth would head up a team of fact checkers which would confirm that claim was actually valid. But he is also responsible for identifying 24 odd facts a week to give to the artists. And he did this over the course of 5 decades of work with Ripley's Believe It or Not. And he lived in New York City. He spoke 14 different languages. So he would read these international newspapers as part of his work process. But he also, 6 days a week for 6 days a week for 10 hours a day, would go to the New York City Public Library, and he would read books. And the librarians there predicted or estimated that, estimated that he would read 7,000 books a year. So in the course of his lifetime, he read 350,000 books as part of his work for Ripley's Believe It or Not. But the point is that Norbert Perlroth is the one who was responsible for checking the claims that were made with regard to these odd facts. And if it didn't pass muster, he would identify that. And so we need to be like Norbert Perlroth as we look at claims that everybody is making when it comes to the science-faith conversation, that we need to make sure that we're checking out people's claims. That would include me, that you should adopt a mindset of skepticism, even towards those things that I would tell you, right? And check it out for yourself, and see if it holds scrutiny. That's our obligation as Christians when it comes to these controversial areas. Not just simply science-faith conversations, but other areas of controversy. We have an obligation before we enter into that discussion to do a little work ourselves, to be open-handed and open-minded and see what the facts actually say. Okay, any questions any of you have? Oh, yes, Cooper.
Yeah, I do have one. I've been kind of thinking about this, and I've been trying to figure out how to put it into words, because it's a bit of a loaded question. But I'm just a little curious, because I know, like, I love science. I support science. I think it's very valuable. I think it shows the world's fingerprint in our world. But I think often, sometimes science can also be used to almost put God in a box. And I'm just a little curious. I want to talk a little bit more into kind of what it looks like for. I don't understand why God couldn't create a universe that was fully equipped and designed with the appearance of age. But I want to go further than that, because I think it goes far beyond appearance. Because I think sometimes, like, from a humanistic point of view, God works outside of time. And I think time is a limit that he is not bound by. Whereas humans, and in our thinking, we often are bound by the limit of time.
Right.
I think it's easy to sometimes get caught up in that time argument. But then you think about the characteristics of God and how God goes about the events of Scripture and the events that we learn from. And it makes me think of, like, if I'm hungry and I want to heat up food, I'm not going to walk outside and sit in the sun and wait for the sun to heat it up over 3 hours. I'm going to put it in a microwave, because that's the way to make sense. I'm hungry and I want to eat it. And I know that's a very human perspective on that. And God even works outside of that.
Right.
But a God of the Bible, a God who is so powerful, I don't see. Sometimes we have to try to explain things that don't always require explanation. That's what I feel like puts God in the box.
Right.
What's your take on that?
Yeah, that's an interesting point, and a couple of thoughts. One is, I think you could also make the counter argument that sometimes we put God in a box, and what science does is reveal to us that maybe God works in ways that we could never even imagine, or that would be very uncomfortable for us, right? So I think it goes both ways, right? And I think it's fair to ask questions like, how do we know that the scientific measurements for age are valid? I think those are fair questions, right? And there are people. One of them is Gerald Schrader, who argues that the universe is both simultaneously old and that God created in 6 days, and he evokes time dilation as the means by which, so that from God's perspective, it looked as if it was only 6 days, but from our perspective, our frame of reference, it looks like it would have been 4.5 billion years with respect to Earth's history. So that's a way in which Gerald Schrader has approached that problem. Right? It's like it's either not either or, but both and. But like when it comes to the appearance of age, keep in mind that God has revealed himself to us through the record of nature, right? And so and he's made us in his image with the capability of studying the world around us, that the world around us is intelligible, and the intelligibility of nature is partly ways in which we can see God's glory, but also it's the way in which we can make use of what's in creation for human flourishing, right? And to care for others, to care for the world that God has made, that understanding. So we have to take a position that nature is reliable, it's intelligible, it's reliable, it's predictable, right? Because that's the nature of God. God is predictable. And there's passages like Jeremiah 33 that speak about the predictability of nature, right? That's absolutely critical. For science to be possible, but for there even to be a moral universe. Like if the laws of nature were unpredictable, or then we can't be held morally accountable, right? Morality is impossible. So it seems to me to be contrary to God's character to argue for the appearance of age, because that would make God seem to be deceptive to me. So that would be my concern with that. But people like Gerald Schrader, I wouldn't agree with him, but I think his approach is a pretty interesting approach, where he's looking to maybe these both are true, right? That they're not necessarily at odds with each other. I don't know.
Yeah, that answers my question. The only response I have is, I know like his response that he put, I think it's like, the analogy I always think of is like, if you have a puzzle, you put the puzzle together, you always use the box top of the puzzle. You kind of see what the puzzle looks like to know where the pieces fall in place.
Yeah.
And if we are one of those puzzle pieces, and we're in the puzzle,
Yeah.
we can see the connecting pieces, and we can almost see
Right.
the evidences for the puzzle that is created. But we can't see the box top, we can't see the table, we can't
Right.
see the room that we're in. And that's all like things that God can see and that He knows, and that's where
Right.
that's where I feel like it gets. That's where I get a little weary and dangerous in like dangerous muddy water sometimes, is because
Right.
I think a lot of people sometimes claim, like the gentleman you just spoke of, claim to have the answers for what that room looks like, what that
Right.
box looks like, without having the ability to see that in the
Right.
place that they are.
Right.
And that's where I'm always like,
Yeah.
I think Scripture gives us enough, and I think God's fingerprint is seen in nature around us, and
Right.
I mean, Scripture's clear. That alone is enough to just show the evidence
Right.
for the Lord.
Right.
But I do always get a little muddy when people try to make claims that are out of their authority to make.
Yeah. Well, I actually am sympathetic to your point. I mean, we have to recognize that our capacity for knowledge is limited, and the knowledge that we have is limited, and that there are these discoveries in science that are completely unexpected, that overturn paradigms that have been long held as being valid. So we always want to be provisional in our scientific knowledge. It's just to me, let's put it this way, I know enough of the science. I'm not an expert in every area of the sciences that deal with dating methods, but I have enough of an understanding of the science that I can go in and arguments intelligently. And I've never seen a claim made by young earthers that the earth is not, that the earth is 6,000 years old, that have actually withstood scrutiny, right? So I'm open to that perspective. I just don't see any evidence whatsoever. Now, so I'm perfectly comfortable accepting that, as a biochemist, this idea of materials being preserved for millions of years is very interesting to me. And so this is an area where I feel like I've got the expertise to actually read the literature and engage. And so you hear this claim, and the claim sounds to be really interesting. It's like, wait a minute, maybe these guys are onto something here. But then when you start to press into it further, it just doesn't hold scrutiny. So the tools I have to evaluate the claim don't tell me that the claim isn't credible, right? So that's my conviction, and so I'm willing to accept science, the mainstream views of science there, and I don't see anything in that view that challenges God as creator, right? I'm also a life scientist, and I'm willing as a life scientist to go against the mainstream thinking in my discipline about evolution, because I think there's actually scientific issues with it, right? So I'm willing to buck the mainstream if I believe that if it represents a threat to what I see Scripture teaching, and if I also see evidence that allows me to raise those challenges, right? So this is the challenge when you're engaged in something like the science-faith conversation. It's a bit of a dance, right? Where you have to be humble, you have to hold on to things provisionally, right? But we also need to be critical. And to me, the thing that maybe grieves me the most is this idea that science-faith conversations have become so divisive in the church. it's not as bad as it was. But man, when I started at Reasons to Believe, it was a battleground. And I think that really creates, I'm not comfortable with the idea that God used evolution to create, but I know a lot of Christians who hold that view. I'm not going to impugn the integrity of their faith or their witness, or I may disagree, and I'll tell you why I disagree, but I don't think that means that we should not acknowledge the position or expose people to that position that we disagree with, right? Right? We should have good conversations with each other. We should challenge each other, and we should do it in a way that helps people who are learning about these areas, who have these questions, to gain understanding, not to force them to take a side.
Gentleness and respect.
Exactly.
Amen. That's the other part that I was
Yeah.
curious to hear you on.
Yep. So to me, if I'm sharing my faith with somebody and they are just utterly convinced that evolution is valid, I would say there are Christians who hold to the idea that God used evolution to create, and here's some great organizations that advocate that position. You might feel comfortable there, right? There's some people that aren't convinced about the credibility of evolution, but they're convinced that the earth is old. Here's a landing, our organization is a landing place. Some people are convinced that Scripture teaches the earth is young, and they accept the arguments made by young earth creationists. That's a place for you to land, right? But it doesn't mean that we can't look at ways to collaborate with one another, with the larger mission at stake, right? Yeah, so that's... Yeah, my objective here is not, if you hold to a young earth view, is not to make you feel uncomfortable or not to make you feel like you need to convert to my position. I'm not, that's not my ministry, is to convert Christians to my position. So, anybody else, thoughts? Okay, well, why don't we come, what time is, lunch is 12:15, right? Okay. Yeah. Okay, so why don't we take, do you guys mind 10 minutes or do you need 15 minutes? All right, let's just come back at 10 after, and then what I've got to say I don't think is going to take more than, the next section isn't that long, I don't think.